Hello and welcome once again to this channel. In today's interesting lesson, I'm going to show you how to derive the formula for multiplying two complex numbers in their polar forms. Let me show you how to do that. Let's assume you have the first complex number in its polar form, which we know as z1 or z sub 1 is equal to 2 cos pi over 2 plus I sine pi over 2, okay? And the second one, which is z2, this is equal to 3, open bracket, cos pi over 4 plus I sine pi over 4. These are two complex numbers in the polar forms, and the number, okay, outside, as this 2 is outside, is called the modulus. 2 and 3 are the moduli of these two complex numbers. The angle, okay, which is pi over 2, is called the argument, right? This is called the argument. Here we have the argument, and this is the real part, while this is the imaginary part. The part that contains an I is the imaginary part, while the part that does not contain an I is the real part. Okay, and they are denoted by Z or Z. And the formula that we're going to use to calculate or to find their product is this one, okay? It says that Z1 times Z2 is equal to R1 times R2. The R here represents their moduli, okay? R1 times R2. Let's assume we want to multiply these two complex numbers. We're going to take first their moduli, which is 2 times 3. Before we start taking their arguments, as you can see here, we have theta 1, which is the first argument for the real part, and this is the first argument for the real part, okay? It's called theta 1. Now, we now pick again theta 2, which is the second argument for the other real part of the other complex number, which is pi over 4. Now, we're going to now go over to the imaginary part. The first argument for the imaginary part is pi over 2, which is, this is z1. So we say theta 1, okay? It is pi over 2, while the second argument for the imaginary part is pi over 4. I'm going to show you how to use this very formula to solve problems in our next video. But for the course of this lesson, we're going to, or in the course of this lesson, we're going to derive this very formula, and I'll show you how it is done. Okay, now we are going to use this, right? The general form is Z1 is equal to R sub 1, okay, multiplied by cos theta 1 plus I sine theta 1. And the next one is Z2 is equal to R2, the R represents the modulus, multiplied by cos theta sub 2 plus I sine theta sub 2. These are the general forms, and with that we can derive this very formula. Now let's write our solution. We're trying to prove this formula or to derive it from this very two. The first thing that we're going to do right here is to say Z1 times Z2, okay, from this one. The first thing to do is to multiply their moduli, this and this, their moduli, okay. We shall multiply them together, okay. Now let's do that. Here we have R1, okay. It's moduli, it's modulus for modulus, okay. Modulus for modulus, and you have R1 times R2, okay. Now if you multiply the two of them, what do you get? You have R1 or R sub 1 multiplied by R sub 2. Now you open a bracket, a very big bracket. We shall use everything, okay, in the first bracket to multiply all the terms in the second bracket. We use everything on the left to multiply all on the right, okay? Now let's begin. For the first one here, we have cos theta 1, okay? Now this cos theta 1 is going to multiply everything in the second bracket. We open our bracket and put everything right here inside here, because this and this are multiplying. So this one multiplies everything here first. Then the second one, which is the imaginary part, also multiplies everything inside here. Now let's perform the operation. The first bracket, the bracket here contains cos theta 2, okay, plus I sine theta 2. We close the bracket. Now let's use the second term in the first bracket to also multiply everything in the second bracket. Here we have plus I sine, okay, theta 1 multiplying everything here. We now have cos theta 2 plus I sine theta 2. Close your square bracket. We can now go ahead and multiply them out. So this is equal to, I'm not going to repeat the z1 plus z2 because of space. This is equal to, we also bring their moduli down. We have r1 and r sub 2. We open our square bracket again, and we multiply out cos theta 1, okay, times cos theta 2. The reason why we did this is so that it's going to be quite easier for us to multiply out. So we shall use cos theta 1 to multiply everything in this bracket for the first one. Then we use I sine theta 1 to multiply everything in the second bracket. Now let's perform the operation. Cos theta 1 times cos theta 2 would give us cos theta 1 cos theta sub 2. Okay, we just multiply the two of them. Now next up, cos theta 1 times I sine theta 2. If you multiply the two of them, I'm going to get plus I cos theta 1, okay, sine theta 2. All right, so this times this will give you I cos theta 1 sine theta 2. Let's take it step by step to avoid mistakes. Plus, let's do for this one, I sine theta 1 times cos theta 2. Let's pick the I first. We have I, let's pick the cos theta 2, okay? It doesn't matter because multiplication is commutative. Whether you take the sine theta 1 or the cos theta 2, it doesn't really matter. You'll still arrive at the same solution. However, I want to pick the cos theta 2 first so that it's going to be easier to work with. So we have our I sine theta 1 times cos theta 2 will give us I cos theta 2. Then this one, sine theta 1. Next up, let's multiply for the I sine theta 1, I sine theta 2. So I times I, okay, would give you I squared. This I multiplied by the I inside the bracket will give you an I squared. Now, next up, what do we get? This one here, sine theta 1 times sine theta 2 would give us sine theta 1 sine theta 2. We close our square bracket. Now, we need to remember that we have an identity in complex numbers that say if you have I squared, this is equal to -1. So wherever we see I squared, we simply replace it with the -1. Okay? If you have I cubed, this is equal to a -I. Okay? I cubed is equal to -I, and I raised to the power of 4 is equal to 1. So this is actually an identity in complex numbers, which you should know. Therefore, what we're going to do is to replace the I squared. Since you have an I squared in this expression, we now replace the I squared with -1. Now let's do that. I'm going to copy everything down so that we would not make any mistake. Here we have r sub 1, okay, r sub 2 multiplied by, here we have cos theta 1, okay, cos theta 2. All right, now permit me to bring the I, okay, I squared this very place because I've seen that we'll end up having a trigonometric identity. I'm going to show you why I'm doing this. So let me bring the I sine theta 1, sine theta 2 this place so that it's going to be easy to simplify. We have plus. Remember that I squared simply means a negative 1. Therefore, we put a negative 1 here, okay, multiplied by sine theta 1, sine theta 2. Now, what else is remaining? We now have everything here. Okay, so right here we have plus I cos theta 1 sine theta 2 plus the next one I cos theta 2 sine theta 1. Okay, we have not really changed anything here apart from replacing the I squared with a negative 1. Okay, so I initially brought down the cos theta 1, cos theta 2 down here. Okay, and I went on to pick this one because it would actually save time, because this one here is going to give us a trig identity that will be very easy to work with, while this one would also give us a trig identity, or will lead us to a trig identity that would also be easier to work with. That's why I brought them together. Otherwise, I would have still simplified them separately before bringing them together. Now, let's go ahead and continue with our simplification. Let me simplify this part. This is equal to r1 or r sub 1 times r sub 2 multiplied by, here we have a cos theta 1, cos theta 2. We copy it down, cos theta 1, cos theta 2. Now, here we have a negative 1. This negative 1 is going to multiply everything here. Okay, so negative 1 multiplied by sine theta 1 is going to give us a negative sine theta 1. And remember that this one is also multiplying sine theta 1. Hence, we have sine theta 2 plus, at this point, let's look at this expression. We have an I on the first term, which is cos theta 1 sine theta 2. We also have an I on the second term, which is cos theta 2 sine theta 1. We can factor out the I, okay, to make it easier for us. Let me factor it out. If I factor out the I, okay, it's now going to multiply everything inside the bracket. And what is remaining? We have cos theta 1 sine theta 2 remaining if we factor out the I. So we have cos theta 1 sine theta 2 plus, remember the I has been factored out, so there is no need of writing it again. The next one is cos theta 2 sine theta 1, cos theta 2 sine theta 1. Okay, this is a very long one, but we can work our way through it. Now, next up, what do we do at this very point? Okay, the next thing to do is that we're going to simplify this very expression right now. Okay, and how do we do that? First of all, I want to rewrite this one. Let me rewrite this one first, because we're trying to arrive at a trig identity, which is called sum and difference identity, that will help us simplify this very part. Let me rewrite it once more. Okay, so rewriting this, we have r1, r2 multiplied by cos theta 1, cos theta 2 minus sine theta 1, sine theta 2 plus, the I comes out as usual. Now, what do we have in the bracket? In the bracket, we have cos theta 1 sine theta 2, but I'm actually trying to get a trig identity that says if you have sine A plus B, okay? This is a sum and difference identity, and this is for the sum. Sine A plus B is equal to sine A, okay, cos B plus cos A sine B, okay? This is where we're supposed to arrive at, and I'm trying to rewrite this expression. I'll bring the sine here, and the cos goes over to where the sine is. Now, the reason why this is actually correct is because multiplication is commutative. It does not matter the order. If you have 3 times 4, you get a 12. If you have 4 times 3, you also get a 12. So in multiplication, the order does not matter, right? Now I'm going to rewrite this right now. I'll bring the sine first. So we have sine theta 2 multiplied by cos theta 1, okay, plus cos theta 2 sine theta 1. All right, so I've succeeded in doing it, and it's not going to be easier to work with. Now look at this. Let's assume you have two angles that are subtracting or two angles that are adding. We can use the sum and difference formula to simplify them. What do I mean? Now for the first one here, we have cos theta 1 multiplied by cos theta 2 minus sine theta 1, okay, times sine theta 2. For this one right here, if you have such an identity, this is equal to, for example, let's say you have um, cos A plus B. Cos A plus B is equal to cos A cos B, okay, minus sine A sine B, okay. This is a trigonometric identity that is very important when it comes to deriving the formula for finding the product of two complex numbers in their polar form. With this right now, we've seen a similarity. We have cos theta 1, theta 2 multiplied by cos theta 2. If you look at here, we have cos A times cos B. If we take our theta 1 to be A, for example, and we take our theta 2 to be B, for example, then here we also take our sine theta 1 to be A and our sine theta 2 to be B, okay? Our theta 1 is A, theta 2 is B, theta 2 is B, and theta 1 is A. We can now see that there is a similarity between these two, okay? Cos A cos B, cos 1 cos 2, okay? Cos theta 1 cos theta 2 minus everything here is equal to this, okay? Now, we are now going to replace everything here with cos theta 1 plus theta 2. Okay, this right now is a trig identity. Okay, it's called the sum and difference formula. Probably you know more about it in my next video where I'll be explaining more about this. But for now, let's stick to the context of this very lesson. So this is our theta 1. Okay, and here is our theta 2. We can say that this is our A and this is our B. While for the next one is our A, okay, our theta 1 is our A, while our theta 2 is our B. Therefore, I'm going to replace everything here with cos theta 1 plus theta 2, because if you have something like this, it's equal to cos A plus B. Therefore, this one here will be equal to cos theta 1 plus theta 2. Let's replace that. Therefore, we shall have, this is equal to R1, R2 multiplied by, remember this is an identity, we now have cos, open bracket, theta 1 plus theta 2, based on the identity that I just showed you previously, plus I. Now for the next one, what do we have? For the next one here, we have that if you have something like sine A cos B, Let me write it down here. If you have sine A cos B plus cos A, okay, sine B, this is equal to sine, open bracket, A plus B. Okay, now let's look at this. Let's say that in this case, okay, our theta 2 is our A, okay, and our theta 1 is our B in this case. All right. Now, if you have sine A, you can say sine A cos B, okay, plus the next one now is theta 2. Remember that our theta 2 is our A. So this theta 2 now becomes our A. And the theta 1, remember that theta 1 here is our B. This one now becomes our B. Okay. So this can be related to something like this. And we now have sine A cos B plus cos A sine B, as we have here, sine A cos B plus cos A sine B is equal to sine A plus B in bracket, right? Now, we've seen that here we have sine theta 2 cos 1, okay? Sine theta 2 cos theta 1 plus cos theta 2 times sine theta 1. It is related to everything here. So that means that we're going to replace all this expression here with something like this. Let me show you what that means. So now we shall have sine, okay, open now brackets. What do we have? Theta 1 plus theta 2. Okay, remember I said this, if you have sine A cos B plus cos A sine B, it is equal to sine A plus B. But in this case, we're using theta, okay? We're using theta. I only wrote these letters to relate it with the identity so that you understand the concept. Now, what we're actually working with is theta 2 and theta 1, okay? So based on this identity, it says that if you have something like this, it has to be written or simplified to this very form. Therefore, we have simplified this, okay, entire expression. We've simplified this to this very point. So we now have I sine theta 1 plus theta 2. This is it, exactly what we have here. So if they're adding up, okay, it's going to be in this very form A plus B, and this is our A, here is our B. I believe you've understood the concept right now. Now, let's finish up here. So we put our bracket. Now, you've seen that this formula has been derived, right? If you multiply two complex numbers in their polar form, this is the formula that you're supposed to use. And this R1 and this Z1 and Z2 has given us something like this. And this is how to derive the formula. It's pretty challenging, but trust me, over time you learn how to do it. Just keep on practicing and practicing. Definitely you'll get there. So all you need to do, if you want to learn how to do this, is you need to know these trig identities, especially for sum and difference. And secondly, you also need to know about algebraic manipulation so that you can know how to manipulate all this to your own favor so that you can arrive at the correct solution. So this is a formula for multiplying two complex numbers in their polar form. I'm going to write it this way. So we have Z1, okay, times Z2 is equal to R1, R2 multiplied by cos theta 1 plus theta 2, okay, plus I sine theta 1 plus theta 2, theta 1 plus theta 2. This is the formula for multiplying two complex numbers in their polar form. So let's assume you're given, let's say you're given Z1 is equal to something like 2 multiplied by cos pi over 2 plus I sine pi over 2. And you're given a second complex number, z2. This is equal to, let's say you have a 3 here, multiplied by cos pi over 4 plus I sine pi over 4. Okay, simply plug them into this formula and solve. This formula helps you to simplify and get the correct solution. All right, thank you for watching this video. I believe it helped you. If you have any questions, any concerns, you can, write it in the comment section, and I'll be right there waiting for you. See you in the next video, where I shall be talking about how to derive the formula for dividing two complex numbers in their polar form. Thank you and bye.